perfect to come down here and do that. We've done it in dry air, but we needed to get some humid air, so we're down here, playing here in Kennedy. You guys are maybe not quite as used to sonic booms as they are out there at Edwards, but you've had your share with the shuttle and some of the other rockets that have come back in here, so we figured this was as good as a place as any to go and try this kind of machine.
Colonel, can you describe your dive, when you're at 40,000 and you dive into creating the boom?
Yeah, so the maneuver that we typically will do is we go outbound to about 30 miles and turn in, and we're about 0.9 Mach, 40,000 feet. When we get to about 25 to 28 miles, depending on how heavier we are, the further out we start the dive. We go to about 10 degrees nose low, full afterburner, and quickly accelerate through Mach 1. And then we level off at 32,000 feet. Usually when we level off, we're probably somewhere right around Mach 1.2. Sometimes a little more, sometimes a little less. We continue the acceleration up to Mach 1.35, then we kind of hold that until we hit the point. Then as soon as we're done, we give it a couple of potatoes, then we start a climbing turn, so it will do what we call defocus the boom out in front of us, so that Cocoa Beach doesn't get blasted, and then turn to the downwind and go back out and do it again.
What's it feel like inside? Can you describe the G-force and what's it feel like when you're doing that maneuver?
Sure. The biggest thing is you're busy. You really don't notice that you've gone Mach 1 other than the HUD says Mach 1.00. So you really don't notice when you go supersonic. If I was level, I'd probably see the altimeter jump back and forth a little bit if I was doing a level acceleration. But then once you're above about Mach 1.15, the altimeter kind of mellows out again and gives you a good accurate reading. But you really don't notice anything. There's really not much G-force involved when you're doing it. But the biggest thing is, just because you're moving so fast, things are happening a lot faster than, going 55 down the freeway.
So you're going supersonic. So does anything change with your equipment? I mentioned you have earphones on, or does anything change with the sound once you hit that barrier that you notice?
That's a good question. Some people ask that all the time. What do you hear in the cockpit when you go supersonic? And I don't hear anything. So in the cockpit, you don't notice it at all. Part of it is the rapid change that you get. So for me, nothing's really changing that rapidly. Even when we go and probe another airplane, so we'll look at what the shocks right next to the airplane look like, and we'll be in another F-18, say probing an F-18. As we move in and out of the shocks, you don't hear any. You will feel the shocks. They will push the airplane around, but you don't feel, like I said, you feel stuff, you don't hear anything.
How do they push the plane around?
Well, what you get is, one, because it's a pressure change, so it's pushing on, say, one wing and not on the other wing. So essentially it'll kind of move you back and forth a little bit, or maybe it's pushing on the nose, but not on the tail, so it might push the nose down, push the tail down or something like that.
Like a little bit of turbulence?
Yeah, yeah.
Okay.
And it's a little bit of turbulence, but almost more like a hand pushing on it, like somebody going out and pushing on the wing or pushing on the nose. So, and it's not real fast or anything like that, so you can compensate it.
Do you ever see things, like do you ever see the cloud kind of develop along your wings or along your nose or anything like that?
No, but you can sometimes see the shock, believe it or not. If you're probing an airplane, you can sometimes, depending on the atmospheric conditions, it looks like a clear line. Other times that you can see it, if the sun is in the right place and I look out on the wingtip, I'll actually be able to see the shadow of the shock wave. And as I go faster, the Mach cone, it gets more acute or more angular, if you will. And it'll move back, and you can actually watch that, as you speed up, you'll look out there and see it moving back on the airplane.
Are you more likely to see it if it's humid, or?
That's a good question. I actually don't know.
Okay.
So I should ask our guys whether they know.
So why is this important? Why is all this testing important? What's the practical applications of this?
Well, we'd like to be able to, I want all you guys to be able to go supersonic too, and not just to go supersonic. It'd be really nice to be able to get to New York in half the time, that it takes now. So one of the ways you got to do this is you got to figure out a way to get that boom shaped or lower in amplitude. So there's a lot of different things you got to look at, and one is the shape of the airplane, but the other is how does that shock wave move through the atmosphere? And one of the things that we're looking at with this is, how does turbulence affect that shock wave? And can we use that to predict what's going to happen to the shock wave so that we can look at it in all kinds of different areas, regimes, problems to make sure that it's not going to be a problem if you're trying to get from, say, Orlando to New York in half the time, or Orlando to LA in half the time.
The plane of the future that limits the amount of shock wave and sonic booms, what kind of plane does that look like?
You know when they banned those lawn dart things that used to throw in the circle? You know, if you're old like me, you remember those? So it looks a lot like a lawn dart. It's a long, skinny nose. They have to really plan the lift distribution. If you look at the low boom demonstrator pictures that are out there, the cockpit is about halfway back. So I'm going to be a good ways back there. The other thing you'll notice is there's hardly any bumps on it. Really long nose, and you can't see out the front of it. So one of the things that they're looking at is high definition television cameras, much like what are around me now, and then also a screen in the cockpit that I'm going to fly off of that I can use to find other airplanes when they're down low and take off and land them.
As a pilot job, how cool is being a test pilot for NASA? How does that rank in the?
Well, being a test pilot is what I always wanted to do. I mean, I decided at age 16 when my high school science teacher handed me a book and said, "Here, read this." And I said, "Why?" He said, "Just read it." And the book was the right stuff. I couldn't put the book down, and I said, "That's what I want to do. I want to be a test pilot, maybe have a shot at being an astronaut." So I then said, "Well, what do you got to do this?" Well, I figured I was going to be an engineer, so okay, engineering degree. Probably need to join the military if I want to fly the things that go fast to do this kind of stuff. So ended up going to the Air Force Academy, getting an engineering degree there, and going off to pilot training, and just kept plodding along until they sent me to test pilot school. And one of the interesting things is, from the day the guy handed me the book to the day I actually finally got to do a test like what I read in that book, it was probably about 15 to 17 years. So sometimes you think, wow, that seems like a long time, but the good thing was it was a lot of fun along the way. So getting to be a pilot, my friends at the Air Force Academy are some of the best friends I have that are out there. So it wasn't like I was just slogging along studying 24 hours a day to get here. It was a great path, and once I got here, it's everything that I thought it would be.
Thank you, sir.